Hello everyone, welcome to my channel GVS Chem. In this module, let us discuss the heat of combustion with different examples and numericals. Please subscribe to my channel, like, share and comment on my videos. Standard enthalpy of combustion. Combustion means burning. Substances burn and give energy, and of course that energy is in the form of heat energy. Now let us see the standard enthalpy of combustion. Enthalpy change accompanying the complete combustion of 1 mole of a substance in excess of air or oxygen, provided all the reactants and products are in their standard state at a specified temperature, is known as standard enthalpy of combustion, or it is also referred as heat of combustion. So if we burn methane, the heat of combustion of methane is also referred as natural gas. So CH4, methane is in the gaseous state, plus oxygen is also in the gaseous state. We get CO2 gas and H2O, it is in the form of liquid. So here this is 2 moles here and of course 2 moles here. Now the heat of combustion is denoted by delta H naught C. So this is the symbol for heat of combustion. Heat of combustion of methane is minus 891 kilojoule per mole. Similarly, heat of combustion of C4H10. What is this? Butane. So C4H10 in gas plus oxygen 13 by 2 gives here 4 carbon dioxide. 4 atoms are there, therefore we get 4 molecules of carbon dioxide, plus hydrogen atoms 10 are there, therefore we get here 5. So 5 oxygen atoms plus 8 oxygen atoms, totally 13. 13 oxygen atoms are required because O2 molecule is there, therefore we take half of the 13, that is 13 by 2. So delta H naught C, heat of combustion of butane, is minus 2658 kilojoule per mole. Now let us do one problem based on heat of combustion. The problem is the chemical reactions taking place in an oven are carbon plus oxygen gives carbon dioxide with 394 kilojoule of energy. Carbon burns insufficiently in oxygen to form carbon monoxide with heat liberated is 111 kilojoule. Coal used in the oven has 80% of carbon by mass. Due to insufficient supply of oxygen, only 60% of carbon gets converted into CO2 and 40% to carbon monoxide. Calculate the amount of heat generated by burning 10 kilograms of coal. Now, mass of coal given equal to 10 kilograms. So, pure mass of coal equal to 80% of 10 kilograms. 80% of 10 kilograms means nothing but 8 kilograms. 8 kilograms, let us take 8,000 kilograms. Now, 60% of carbon gets converted into carbon dioxide. Therefore, amount of carbon converted to carbon dioxide equal to 60% means 60 by 100 into 8,000. This is nothing but 4,800 grams. On the other hand, amount of carbon converted to carbon monoxide equal to how much? This is 40%. So 40 by 100 into 8,000. This is nothing but 3,200 grams. 3,200 grams. Now C plus O2 gives CO2 plus 394. The amount of heat liberated is 394 kilos. Now this is 12 grams. 12 grams releases this much. What is the amount of heat converted to carbon dioxide? 4800. How much? So this is 4800 by 12 into 394. This is nothing but 1576 kilojoule. On the other hand, 40% of carbon converts to carbon monoxide. So C plus O2, this is half O2 gives CO. Amount of heat liberated here is 111 joule. So 12 grams give 111, whereas 3200 gram gives how much? So 3200 by 12 into 111. 4 here 3 times, 4 here 8 times, 3 here 37 times. Therefore, amount of heat liberated is nothing but 29,600 joules. Now, total heat liberated equal to total heat liberated. Previously, how much we got? 157600 plus 29600. So this is nothing but 187200. This is joule. So this joule can be converted into kilojoule. 1 kilojoule equal to 1000 joules. So if you divide this by 1000, we get. So amount of heat liberated equal to 187.2 kilojoule. So scientifically it can be written as 1.87 into 10 to the power 2 joule. So this is the amount of heat liberated. We take a variety of foods for getting our energy for performing different activities. So in our food, mainly carbohydrates and fats give energy. Carbohydrates and fats give energy. Carbohydrates means, say, when we take food means it is in the form of starch. Starch digests and finally converts into glucose. This glucose dissolves in blood. Glucose dissolves in blood. So the blood in glucose, it combines with oxygen during the respiration. And of course we get carbon dioxide plus water vapor. Apart from this, energy is released, and this energy is nothing but, so here delta H equal to minus 2900 kilojoule. That is, when 1 mole of glucose undergoes oxidation during the respiration in our lungs, it releases this much amount of energy, that is 2900. This energy is used for performing the various activities on day-to-day basis. By taking different foods, how much energy do we get? Therefore, we can compare. So this can be compared by using the word, that is term calorific value. Calorific value of food or fuel is the amount of heat liberated by complete combustion of 1 gram of any substance. So the amount of heat liberated by the combustion of 1 gram of any substance means it may be either food or fuel. It is known as a calorific value. So the calorific value of curd is 2.5 kilojoule. This is 2.5 kilojoule per gram. Similarly, calorific value of milk is 3.2 kilojoule per gram. So by using this calorific value, we can understand, we can know how much amount and what type of foods we have to take for our daily consumptions. And of course, you know that when we take excess amount of food, the excess amount of food we take in, it stores as a fat, and of course the body gets obese. Now based on calorific value, let us do one more problem. The problem is, burning of 39 grams of benzene produces 1632.3 kilojoule of. Calculate the heat of combustion and calorific value of benzene. First of all, the equation for reaction. equation for reaction is benzene C6H6 liquid plus oxygen gives CO2 plus H2O. CO2 is gas, H2O is liquid plus what is the amount of energy plus 1632.3 kilos. So here 6 carbon atoms are there, 6 carbon atoms are there, here 3. Therefore totally 6 to 12 plus 6. 6 carbon atoms are there, therefore 6 carbon atoms need 12 oxygen atoms and 6 hydrogen atoms need 3 oxygen atoms. Therefore 6 to 12 plus 3, 15. But here one molecule has 2 atoms, therefore this is 15 by 2. Now here during the combustion means heat releases. Heat releases means it is negative. Now what is the mass of benzene given? Mass of benzene given equal to 39 grams. Molar mass of benzene equal to 6 into 12, 72 plus 6, 78 grams. Therefore, mass of benzene and heat released. 39 grams releases 1632.3, whereas molar mass is 78. 78 releases how much? Therefore, this is nothing but 78 by 39 into 1632.3 is equal to, this is 3264.6. This is kilojoule. Of course, heat released means in answer we have negative sign. Now we can find the calorific value also. Calorific value. How do we calculate calorific value? It is the amount of heat liberated by burning 1 gram of the substance. So 78 grams, or you can take 39 grams. 78 grams release 3264.6 kilojoules. Then 1 gram, that means divide this value by 78. Therefore 3264.6 by 78 is equal to, this value is 41.85. This is kilojoule per gram. Kilojoule per gram. So this is the unit of calorific value. Let us do one more problem. Heats of combustion of hydrogen and butane are 300 kilojoule per mole and 2658 kilojoule per mole respectively. Compare their efficiency. So how do we compare the efficiency? By comparing the amounts of heats liberated by the same amount of substance. So here we can take the calorific value. Calorific value is nothing but, calorific value means heat given by 1 gram of the substance. 1 gram of the substance. Whereas what is the information given? Heat of combustion. Heat of combustion means amount of heat liberated by 1 mole of the substance. Therefore, amount of heat liberated by 1 mole of hydrogen is equal to 300 kilojoule per mole. What is the 1 mole? 1 mole of hydrogen is nothing but 2 grams. So 2 grams give 300. 1 gram how much? 150 kilojoule per gram. Right. Now, what is this butane? Butane, molecular formula of butane is C4H10. What is the molar mass? molar mass equal to 4 into atomic weight of carbon is 12 plus 10 into 1. This is nothing but 48 plus 10 equal to 58 grams. So 58 grams of butane, butane gives 2658. So 1 gram gives how much? 2658 by 58. This is nothing but 45.82 kilojoule per gram. So out of which is the best fuel? Because hydrogen gives high amount of energy per gram, that is its calorific value is very high, therefore hydrogen is the best fuel. Therefore hydrogen is the best fuel. In the next module, let us discuss the different enthalpy changes during reactions. Please subscribe to my channel, like, share and comment on my videos. Thank you.